Penicillin is an interesting antibiotic that helps in prevention of bacterial cell growth, especially by inhibiting the enzyme required for synthesis of a bacterial cell wall. So we can say that penicillin inhibits the enzyme which is needed for synthesis of bacterial cell wall. Just consider the structure of penicillin. Here we have a two-membering system. One is known as the beta-lactam and another is a 5-member thiazolidine ring. This 4-membering system is known as the beta-lactam. And in fact, the biological activity of penicillin is linked to this 4-membering system. The another is a 5-membering system, which is thiazolidine ring, and this specific example of penicillin is known as penicillin G. Here we have a side chain as well that vary depending upon which penicillin we are going to discuss. Another important and closely related class of antibiotics is known as cephalosporin, which also have a 4-membering system. This is also known as a beta-lactam as well. Because it also has a 4-membering system. So we are going to focus on biological activity, and we will check out how penicillin inhibit the growth of a bacterial cell wall by interacting with the enzyme, especially transpeptidase, which is required for synthesis of bacterial cell wall. If the enzyme is neutralized, then definitely there will be no synthesis of bacterial cell wall, and as a result the growth will be affected, so the bacterial culture will be stopped. So let's consider the mode of action. Here we have an example of enzyme. This is an active enzyme which is known as transpeptidase, which has a hydroxyl group as well. This hydroxyl group interact with a carbonyl group of beta-lactam. Here we have shown, and it attacks the carbonyl group. Rearrangement take place. This is especially a penicillin molecule. An enzyme is interacting with the penicillin molecule, and we get an intermediate structure that rearrange. Here the carbonyl group has attacked, and this electron pair rearrange, and ultimately it gives rise to this structure which is known as acylated enzyme. In other words, we can say that the enzyme has been acylated by penicillin molecule, so this is inactive enzyme. Once this enzyme is inactivated, it no longer help in synthesis of bacterial cell wall. Consider the mechanism again. This is an enzyme which is known as transpeptidase. It aids to the carbonyl group of beta-lactam ring via its hydroxyl group for giving an intermediate complex that rearrange, and ultimately we get an inactivated enzyme which is no longer capable of synthesizing the cell wall of a bacterial cell. As far as bacteria are concerned, usually they develop resistance with the passage of time. Usually it takes 15 to 20 years for bacteria to develop a resistance. 20 years bacterial develop resistance. And in fact it was Alexander Fleming, who said while he was receiving his Nobel Prize 1945 that there is a danger that the ignorant man may easily underdose himself with antibiotics because if we increasingly use antibiotics, definitely the bacteria will learn how to neutralize it. As a result, the bacteria will develop a resistance to such an extent that the use of antibiotic will be useless. So that's why Alexander Fleming, the discoverer of penicillin, said that the use or the repeated use of penicillin can develop a resistance. So when the resistance is developed, usually the penicillin is no longer capable to neutralize the bacterial enzyme needed for synthesis of cell wall. Usually bacteria develop an enzyme which is known as penicillinase. This is an enzyme which is used to neutralize the penicillin, especially resistant bacteria develop penicillinase to counter the attack of penicillin. For example, we will check out how this enzyme interact by neutralizing the active penicillin. Especially this enzyme also has, let me sketch the structure. Let's suppose, for example, this is a penicillin or penicillinase, a new enzyme. It has a hydroxyl group like the previous transpeptidase enzyme, and it also has an amino group as well. So both functional groups are present in the new enzyme, especially which is developed by the resistant bacteria. So whenever a penicillin come to interact with the bacteria, so it first react via hydroxyl group of the new enzyme and making the complex which ultimately neutralize or hydrolyze. For example, when this penicillinase, let me write over here, this is a resistant bacteria new enzyme which is penicillinase. When it reacts with penicillin, it gets a complex which is hydrolyzed to an acid, and this acid is known as penicillinoic acid. In fact, this penicillinoic acid is no longer capable to interact with the active enzyme that is transpeptidase. So by this way, the resistant bacteria neutralize the action of penicillin by making penicillinoic acid. So how to counter this threat to penicillin? Especially organic chemists synthesize different derivatives in order to neutralize the action of penicillinase. A new technique which is known as drug synergism. This is a technique in which another drug is used in combination with the penicillin so that it could help in neutralizing the resistant bacteria against the action of penicillin. Usually the organic chemists synthesize a new compound which is used in combination with penicillin so that the penicillin can't be neutralized by the enzyme, especially in the new enzyme developed by resistant bacteria which is penicillinase. So let's check out how this threat can be countered. For example, sulfone are usually made here in drug synergism. Sulfone are used in combination with penicillin. These sulfone neutralize penicillinase enzyme, where penicillin neutralize transpeptidase enzyme. As a result, the synthesis of cell wall is inhibited even in resistant bacteria as well. So this combination of two or more drugs is known as a drug synergism. One drug is used for neutralizing the penicillinase, and another drug is used for preventing the synthesis of bacterial cell walls by inhibiting the transpeptidase enzyme. Let's check out drug synergism. Usually sulfone is used in combination with penicillin for getting the desired action against resistant bacteria. The sulfone is usually made from penicillin when it is treated with per acid, such as this, and we get a sulfone of penicillin. Just take an example. Here we have let me clarify. This is a penicillin. Here we have a side chain. Let me call it an alkyl group, carbonyl group right over here. So when this is treated with the per acid, we get a sulfone like this. In other words, in sulfone we have oxidized the sulfur for getting the sulfone. Usually the per acid is used for oxidation of sulfur to get the sulfone, and this sulfone is very important for neutralizing the action of penicillinase enzyme. Consider when penicillinase, as we have stated in the previous example, just let me sketch right over here. Penicillinase enzyme, this is an enzyme that is produced by a resistant bacteria. It has hydroxyl group just like a transpeptidase enzyme, and we also have an amino functional group as well on this enzyme. So when it interacts with here we have a carbonyl group as well. So whenever penicillinase come into vicinity of sulfone, here let me sketch the sulfone. This is sulfone of penicillin. So the hydroxyl group will attack the carbonyl group of beta lactam, much like the hydroxyl group of transpeptidase, which attacked the beta lactam ring, and we get a complex like this. This is an enzyme, newly attached enzyme. And we have a carbonyl oxygen which rearrange like this. And this nitrogen is then protonated and we get the structure. This is an attached enzyme. This is sulfone. Let me clarify it a bit. Which rearrange and we get a new structure. Let me draw only the 5-membrane system. Here we have a nitrogen, and this is the rest of the molecule. Here we have a carboxyl group, 2-methyl group, and SO2 group. So this is an imine functionality which is stable, and the substrate, especially the amine, is susceptible to nucleophilic attack of amino group. So this amine is susceptible to another nucleophilic attack of especially the amino group attached on the penicillin, and we get a cyclic structure. By this way we see that it is neutralized. Let me consider again. This is the NH2 group. Let me to take this carbon atom of the amine, and we get this is a new enzyme. The structure further rearrange. Here we have nitrogen lone pair that rearrange, and we get inactive enzyme. And the group which is released after. Here we have a negative charge as well. So by this way we can say that the penicillin leaf has been inactivated, and no, the penicillin is required especially for neutralizing the transpeptidase enzyme in order to inhibit the bacterial cell growth. So let me revise the important concepts again. Usually drug synergism is a combination of two or more drugs which are used for especially resistant strain of bacteria. In case of penicillin, in order to make penicillin useful against bacteria, sulfone are used for preventing the action of penicillin leaf that is synthesized by resistant bacteria. So the sulfone is usually made from penicillin by treating penicillin with peracid. So we get the oxidation of sulfur right over here. I have shown the reaction. The sulfur is oxidized in the presence of peracid to a sulfone, and the sulfone is used in countering the action of penicillin leaf. Here we have shown the action, especially on penicillin leaf. We have two functional groups such as the hydroxyl and amino group. The hydroxyl group add to the sulfone, especially I have shown the mechanism right over here, just in similar fashion like transpeptidase enzyme adds to a penicillin beta-lactam ring. So here a different structure has obtained, and ultimately we get an amine which is a good substrate. So this amine is then reacts with the amino group especially of penicillin leaf, and we get the structure like this. By this way the penicillin leaf is neutralized. Now the penicillin work after. At first instance, especially in this drug synergism, the sulfone acts upon the penicillin leaf, which is an enzyme synthesized by a resistant bacteria, and in the second sense the penicillin acts on transpeptidase enzyme. So sulfone acts on penicillinase enzyme of resistant bacteria, and then the penicillin acts on transpeptidase by inhibiting the cell growth. So by this way the bacterial cell or synthesis of cell wall is countered. As a result, the growth is inhibited. Here we have shown a simple action. This is action in which enzyme added to beta-lactam ring. So this is all about the penicillin mode of action. I hope the video has clarified your concept about how the penicillin acts on a bacterial cell wall in the first instance, and later on drug synergism entails or give us information how two or more than two different drugs are used for especially for countering the resistant strain of bacteria. For example, we can also use more than two example of drug as well in order to make the action of a drug workable on a resistant strain of bacteria. Thank you for watching the video.